In the last two examples, we saw this for this magnesium hydroxide, that if you had hydroxide, it was like 0.1 molar, there it is, of hydroxide in the solution, the solubility went down significantly. And as we said, this is inconsistent with Le Chatelier's principle. Okay, the other place that we're going to use this Q, right, the factor, is by calculating the concentration or the solubility product, right, but and see whether it's larger or smaller than the fixed KSP. So if that Q comes out larger, that means that you will have a solid present, or something, meaning that a precipitate will form. And if Q is less than KSP, then a precipitate won't form. Example number 22, 25 milliliters of a 0.05 molar sodium carbonate and 10 milliliters of 0.002 molar calcium nitrate are mixed. Will a precipitate form? And we already have KSP. Well, this kind of problem, you don't really need to do a Rice table, or sorry, you don't need a Solubility table because nothing's reacting. And a Rice table, it's simple enough since you're just going to plug in to KSP, because you're just trying to see if the Q is greater than or less than KSP. But what you need to figure out are the concentrations that you're going to need. So we're going to need the calcium and the carbonate concentration. And each of these is being diluted. So you have the calcium 2 plus, and it's starting off with 10 milliliters. I'm essentially doing the dilution equation, M1V1 equals M2V2. Because you're starting off with 25 milliliters of 0.05 molar, 10 milliliters of 0.002 molar calcium nitrate, right? That dissociates. We don't care about the nitrate, but the calcium is 0.002 molar, but it ends up being diluted from 10 milliliters where it starts to a total of 35 milliliters, because in the end, there's now 35 milliliters. So this is the same as M1V1 equals M2V2. It's 10 milliliters times 0.002 molar over 35 milliliters. That's the new volume. So the concentration of calcium ends up being 5.71 times 10 to the minus 4. And you do the same thing for the carbonate, but it starts off with 25 milliliters and it's diluted to 35 again. And it started off with 0.05. So that comes out to 3.57 times 10 to the minus 2. All right, so then the Q that we're looking for is going to be the calcium times the carbonate, which is going to be just the product. Product of those two different concentrations. In this case, nothing is squared or anything like that. All right, so if something had been squared, you would have to figure it out, or if it had been more than one in solution. This one was simple enough. Okay, so that Q ends up working out to be 2 times 10 to the minus 5. And since that's larger than the 8.7 times 10 to the minus 9, so precipitate forms. Right, because this is equal to KSP. Q is greater than KSP. Okay, why don't you try number 23? Similar problem, although that's a similar problem. Try that. Okay, so we have iron, and it's going to be 100 milliliters into 300 milliliters, because we're adding 100 to 200, and it started off with 0.05 molar. So that ends up with, and then the carbonate starts off at 1.5 times 10 to the minus 2. And it gets diluted from 200 to 300. Which makes it 1. So Q is equal to iron. That should be, iron should be 2 plus. Carbonate. .167 times 0.01 equals 1.7 times 10 to the minus 4, which again is greater than KSP. So a precipitate forms. I should really have put a more difficult problem in here also, because these are very simple, one-to-one. If we had done something that was more difficult, which you'll probably see in the homework, you have to pay more attention to what the concentration that you're getting, because for instance, if it was hydroxide, like calcium hydroxide, you have to remember that there are 2 hydroxides when it dissociates. All right, number 3 is a slightly different problem, but you might be able to handle it. It's again a precipitation problem, but the question is, typical ion concentration in urine is 2 times 10 to the minus 3 molar. What's the minimum concentration of phosphate ion that would just begin to precipitate calcium phosphate? Okay, so you need to figure out how much phosphate will precipitate calcium phosphate. So again, why don't you try turning off the video, seeing if you can figure this out, and then I'll do it for you. Okay, so at precipitation, right, that's when, Q is going to equal KSP at that point, right? So that means Q is going to equal 10 to the minus 26, which is going to equal the calcium and the phosphate. But the calcium is to the 3rd power, and the phosphate is to the 2nd power. So this is a little more challenging. All right. Now what do we know here? We know that the urine has, the calcium is 2 times 10 to the minus 3. So we can plug in that for the calcium. Cubed. And so what we're looking for is the phosphate concentration. It's easier to solve it if you call it X. All right. So when you do that, you get 10 to the minus 26 is this number here. You can divide both sides by 2 times 10 to the minus 3 cubed, and then take the square root. You end up with X is equal to 1.1 times 10 to the minus 9. You have to remember what you were solving for. Of course, oops, and that is a concentration.